In this lesson, we focus on the practical reality of AI careers and team structures in modern organizations. Whether you are an engineer considering a transition into AI or a professional already working in machine learning, understanding the landscape of roles, specializations, and collaboration patterns is essential. This is not about motivation or hype, but about the concrete choices you will face, the career progression you should expect, and the organizational dynamics that shape success. By the end of this lesson, you will understand how AI teams are structured, what different roles actually do, and how your skills and interests map to sustainable career paths in both industry and research environments. Our objectives today cover five critical areas. First, we will clarify what different roles actually do, moving beyond job titles to real responsibilities. Second, we will examine how teams are structured in practice, from startups to large technology companies, and how different functions communicate. Third, we will discuss career progression honestly, including growth opportunities, plateaus, and transitions. Fourth, we will map specific skills to roles and career stages, helping you understand what technical depth and breadth matter most. Finally, we will point you toward legitimate resources for learning and community engagement. Throughout, we emphasize practical reality over aspirational thinking. The ML engineer role has become increasingly important as organizations move from experimentation to production. Unlike research focused work, ML engineers own the entire life cycle, taking a model from prototype to deployed system, managing its behavior in the real world, and ensuring it meets business constraints. In real AI teams, ML engineers spend significant time on infrastructure, monitoring, and debugging production systems, not primarily on inventing new algorithms. This role requires depth in software engineering, distributed systems, and data infrastructure. Common misconceptions exist about what this role entails. Many engineers expect daily work on model optimization or novel architectures, but the reality is more about reliability, performance profiling, and technical debt management. Your career progression in this role depends on demonstrated ability to ship systems, not just train models. In hiring decisions, companies look for evidence of having built production systems, not just Kaggle competition wins. These three roles are often conflated, but they are fundamentally different in practice. Data scientists focus on understanding data, formulating problems, and testing hypotheses. They operate in ambiguity and spend time in notebooks. ML engineers take a validated model and build systems around it, focusing on performance at scale. Data engineers ensure the entire data infrastructure is reliable, efficient, and accessible. In many early stage startups, one person does all three. In mature organizations, these are separate career tracks with different compensation, advancement opportunities, and technical stacks. Understanding which aligns with your strengths is critical. Many professionals discover too late that they prefer infrastructure work over statistical modeling, or vice versa. This distinction affects hiring decisions. A startup may hire a generalist, but a growth stage company will evaluate which role you are truly suited for. Your career growth depends on becoming excellent in one track while maintaining breadth in adjacent areas. Research scientists operate in a different ecosystem than industry practitioners. Their role is to push the boundaries of what is possible in AI through novel techniques, theoretical insights, and empirical breakthroughs. In large technology companies like Google, Meta, and Microsoft, research teams exist alongside product teams. In academia and dedicated research institutes, this is the primary function. A critical reality, research roles often pay well but may involve less influence on products. Additionally, the path is often narrower, with limited upward mobility outside research. Early career researchers should understand this trade off. The skills required differ significantly. You need stronger mathematical foundations, comfort with ambiguity in open ended problems, and ability to evaluate your own work rigorously without external validation. Many engineers transition from industry to research, but the reverse is less common. If you are considering a research track, understand that your long term growth may depend on publication record, conference visibility, and reputation in the research community, not product shipping metrics. MLOps is one of the fastest growing specializations in AI, and for good reason. As organizations deploy more models, the infrastructure burden becomes acute. MLOps engineers design platforms that allow data scientists and ML engineers to work productively without manually managing compute, data, and model versioning. This is highly technical infrastructure work, but specialized for machine learning contexts. In real teams, good MLOps engineers are in extremely high demand because they unblock entire teams and prevent costly mistakes. Common misconceptions: MLOps is not just DevOps applied to ML, and it is not primarily about tools or open source platforms. It is about designing systems that make safe, fast iteration possible. Your career here is strong if you enjoy both software engineering and understanding ML workflows at a deep level. Compensation is often competitive with senior ML engineers, and career growth is visible in your ability to accelerate team velocity. If you are burned out on model tuning or feel more excited by infrastructure, this is a legitimate and respected career path. Product managers working on AI products face a unique challenge. They must understand technical constraints deeply enough to make good decisions, yet maintain business focus. The role involves translating algorithmic capability into user value, which is not straightforward. A high accuracy model may be worthless if latency is poor or cost is prohibitive. Good AI product managers understand this trade off space and are willing to say no to technically elegant solutions that do not serve the product. This role is less common than ML engineer or data scientist roles, but increasingly valuable. Many AI products fail not because the ML is weak, but because the product strategy was flawed. Early in your career, if you are considering this path, spend time in ML engineering first to build credibility. PMs who lack technical depth are ineffective in AI contexts. If you transition from ML engineering to product management, your technical credibility remains a major asset. Compensation is typically high, and career progression is visible in your ability to influence company strategy around AI. AI ethics and policy is one of the fastest emerging specializations, driven by real world consequences of deployed AI systems and increasing regulatory scrutiny. These roles exist in technology companies, consulting firms, government agencies, and nonprofits. Unlike traditional ML roles, this is inherently cross functional and often less technical, but not non technical. You need enough technical knowledge to assess AI system behavior, identify bias, and understand trade offs. However, the role also demands understanding of social science, regulatory environments, and communication with non technical stakeholders. This path attracts thoughtful engineers who are concerned about impact beyond metrics. Career growth here depends on building reputation in the emerging ethics and AI governance space. Compensation is often lower than pure ML engineering, but job security and impact can be high. A misconception: this is not primarily about academic fairness literature, but about practical choices in deployed systems. If you pursue this path, develop expertise in at least one application domain, such as hiring systems or financial lending, and deepen your understanding of the regulatory and social context. Effective AI teams are intentionally designed, not randomly assembled. In startups, you often see small teams of 3 to 5 people, where everyone does multiple roles. This requires flexibility and breadth. In growth stage companies, you see more specialization, dedicated data engineers, ML engineers, and sometimes researchers. In mature organizations, you see distinct teams for different products or domains, with deeper specialization within each. A critical lesson from industry experience: the best teams have people who respect each other's specialization and can communicate across technical boundaries. A data scientist must understand data engineering trade offs. An ML engineer must appreciate why a model choice matters. This mutual respect prevents silos and poor decisions. Another key insight: role clarity matters enormously. Ambiguity about who owns model deployment, monitoring, or the data pipeline creates friction. Mature teams have clear ownership models and escalation paths. If you join a team with unclear roles, expect slower progress and frustration. As you advance in your career, your ability to work effectively across roles becomes increasingly valuable. One of the most common failure modes in AI projects is poor cross functional collaboration. A data scientist may build a highly accurate model that is impossible to deploy. A product team may have unrealistic expectations about what is achievable. Business stakeholders may not understand the ongoing cost of maintaining a deployed system. These disconnects are avoidable through deliberate collaboration early and often. In real successful teams, data scientists attend product meetings and business reviews, product managers spend time understanding technical constraints, engineers push back on requests that are not feasible. This requires people who can translate between worlds. If you are technical, developing communication skills is not optional. It is essential for career growth. If you struggle to explain your work to non technical audiences, your impact will be limited. Another practical point, early involvement matters. If you are brought in after a problem has been defined, you inherit constraints. If you are involved from the start, you can shape the problem statement itself. This ability to influence problem definition is a mark of senior practitioners. The pace of change in AI is real, but often exaggerated. Fundamentals like linear algebra, optimization, and software engineering have not changed in decades. What changes is implementation details, tools, and the specific techniques that are practical at scale. A critical insight for sustainable careers. You do not need to learn every new model or technique. You need to understand the landscape well enough to evaluate what matters for your specific problems. Reading a research paper thoroughly takes hours. Understanding that it exists and what it addresses takes minutes. Both have value, but at different career stages. Early in your career, invest in deep fundamentals. As you progress, maintain breadth through reading and community engagement. Another often overlooked source of learning is production work itself. Debugging a failing model in production teaches lessons that papers and courses do not. Burnout in AI often results from trying to learn everything at once or feeling pressure to stay on top of every new development. Sustainable learning means being strategic about what you invest in. Learning resources are abundant, but choosing wisely matters. Formal courses provide structured progression and depth. University level courses like those from Stanford and MIT are high quality but require significant time commitment. Andrew Ng's courses are accessible and practical, good for learning specific tools and frameworks. However, courses alone do not build the judgment and experience needed for senior roles. Open source contributions are invaluable because you work on real problems with real constraints. Kaggle competitions teach modeling under specific constraints and expose you to diverse datasets, but they are not representative of production problems. Research communities matter if you want to stay on the frontier. Reading papers, attending conferences, and engaging with researchers shapes your understanding of what is possible. For most practitioners, a mix of formal learning, practical project work, and community engagement is optimal. Mentorship matters too, often more than self directed learning. A good mentor points you toward what matters and away from distractions. If you do not have a mentor, seek one actively. As you progress, finding people 1 to 2 steps ahead and learning from them accelerates growth far more than any course. Your portfolio is how potential employers and collaborators assess your actual capabilities. A common mistake is prioritizing breadth over depth. 10 tutorial projects are less impressive than one serious project from conception to maintenance. Employers want evidence that you have shipped something, dealt with real data complexity, and maintained a system over time. This is why open source contributions matter, but not all contributions equally. A pull request fixing a typo is not the same as developing a new feature or refactoring critical infrastructure. Writing about your work is underrated. If you build something non trivial, write about it. Explain the problem, your approach, trade offs you made, and lessons learned. This serves multiple purposes. It clarifies your own thinking, demonstrates communication skills, and provides proof of depth. Domain expertise is valuable. Rather than knowing shallow aspects of many domains, being strong in one area, whether healthcare, finance, or recommendation systems, gives you credibility and makes you more useful on real teams. Your portfolio should reflect intentional growth, not random projects. As you advance, your portfolio becomes less important than your reputation and proven impact, but early in your career, it is critical. The AI career landscape is evolving in predictable directions. Specialization is increasing because organizations realize that general purpose ML teams are inefficient. A team focused on recommendation systems, for example, develops domain expertise that a generalist team does not. New roles emerge as organizations mature. Roles that were non existent 5 years ago, like MLOps engineer or responsible AI engineer, are now standard. The skills that matter are shifting. Strong software engineering fundamentals are becoming as important as statistical knowledge, if not more so. The ability to reason about systems, complexity, and scalability matters on every team. Remote work has increased access to global talent pools and given people more flexibility in where they work. This is unlikely to reverse entirely. Finally, there is growing focus on efficiency and sustainability. As AI models become larger and more resource intensive, building systems that are computationally efficient and mindful of environmental impact is becoming a competitive advantage. Teams that can deliver results with less compute are outcompeting those that cannot. These trends shape which skills and roles matter most. As we conclude, here are the core takeaways that should guide your career decisions. First, recognize that AI encompasses diverse roles with different day to day work, growth paths, and outcomes. There is no single correct path. What matters is understanding yourself, your strengths, and what sustains you over a long career. Second, invest in clarity about what you actually enjoy. Many engineers discover too late that they prefer infrastructure to modeling or research to production because they never ask themselves directly. Third, excellence in any AI career requires both specialization and breadth. You develop deep expertise in one area because that is where you have impact, but you maintain enough knowledge in adjacent areas to collaborate effectively and pivot if needed. Fourth, recognize that the quality of your team and your ability to work across roles determines your effectiveness and satisfaction. Technical skill alone is insufficient. Finally, sustainable AI careers are built on learning, community, and mentorship, not hype or rapid tool adoption. You are investing in decades of work. Choose paths and people that sustain you.